Hey there, stargazers, buckle up because we're about to embark on a fascinating journey through the cosmos. Our story begins with a recent and thrilling discovery by the European Space Agency. Imagine a vast, empty expanse of space. Now imagine finding a hidden treasure within it. That's right, the scientists stumbled upon a celestial body in the void of space, something that had only been a hypothesis until now. This discovery was so exciting that it made it into the archives for everyone to see. Let's rewind time a bit to about 100 years ago. Back then, humanity had a much smaller view of the universe. We believed there were fewer than 50 billion stars in the entire cosmos. It made sense though, 50 billion stars seemed like a lot, and the idea of other galaxies wasn't even on our radar. But then, along came Hubble, who discovered that what we called the Andromeda Nebula was actually a massive galaxy, even larger than our own Milky Way. Fast forward to today, and we know there are at least 100 billion galaxies out there. Mind-blowing, right? Now let's talk about our home galaxy, the Milky Way. In the past, scientists thought there were fewer than 50 billion stars here. Why? Because they didn't know about red dwarf stars, which are too faint to be seen with the naked eye. But now we know that these red dwarfs make up a whopping 80% of all the stars in our galaxy. This new information bumped up the estimated number of stars in the Milky Way to somewhere between 200 and 400 billion. Even with all this knowledge, we discovered something astonishing in the 21st century. The gravitational pull of our galaxy is almost 6 times greater than the combined gravitational forces of all its stars. This led scientists to hypothesize the existence of dark matter, a mysterious, unseen mass that we have yet to identify. Jumping back to the present, let's dive into the world of exoplanets. Over 5,000 exoplanets have been discovered so far using various indirect methods. However, last year, a new type of celestial body was found, one that doesn't belong to any star system. These are called planemos, or free-floating planets, FFPs. Unlike the planets in our solar system, which orbit the Sun, these planets wander through the galaxy without orbiting any star. How do they end up like this? Some are ejected from their star systems, while others form with too little mass to become stars. Theoretically, there should be a huge number of these FFPs in our galaxy, but finding them has been incredibly challenging. To understand why, let's look at this chart. It shows the conditions under which a planet can be detected based on its distance from Earth and its size. The horizontal axis represents the distance, and the vertical axis represents the size. Larger objects can be detected from farther away, while smaller ones need to be closer to be spotted. For instance, if there were a planet the size of Jupiter in our solar system but 2000 AU, 0003 light-years or 300 billion km away, we wouldn't be able to detect it with our current technology. This difficulty in detection explains why we still speculate about an undiscovered 9th planet in our solar system. Given this challenge, imagine how hard it is to find FFPs in a galaxy that spans 100,000 light-years. But this year, TESS, the Transiting Exoplanet Survey satellite, managed to detect its first FFP. Soon after, the European Space Agency discovered multiple FFPs using the NISP, Near-Infrared Spectrophotometer, on the Euclid spacecraft. These FFPs were all several times larger than Jupiter, which suggests that there may be far more of these wandering planets than we ever imagined. This is significant because, just as red dwarf stars make up 80% of the stars in the Milky Way, FFPs might be far more common than we thought. Smaller celestial bodies form more easily than larger ones, which could mean that FFPs are extremely abundant. If this hypothesis is correct, there could be tens or even hundreds of times more FFPs than stars in our galaxy. This discovery could change our understanding of dark matter. The concept of dark matter arose because we assumed most of a galaxy's gravitational force came from its stars. But if there are trillions of FFPs, many of which are massive gas giants, their combined gravitational force could rival that of all the stars. Since non-stellar objects like planets are nearly impossible to detect with telescopes, it's plausible that the gravitational force we can observe is underestimated. While planets alone can't account for the 6-fold discrepancy, the combined mass of FFPs and other objects like stellar mass black holes and intermediate mass black holes might explain the missing gravity. This suggests that the concept of dark matter may stem from the limitations of our observational technology, which can't even detect a planet 0.03 light-years away. In summary, the discovery of these free-floating planets opens up a whole new realm of possibilities. It challenges our current understanding of the galaxy and the mysterious forces that govern it. Who knows what other secrets the universe holds? One thing's for sure, our journey to uncover the mysteries of the cosmos has only just begun.